To determine if a pool requires bonding, firstly, measure the pool depth. If it exceeds 42 inches, it is considered a storable pool and requires bonding. Secondly, check all pool walls for metal components. If there are any metal walls or supports, the pool is considered a permanent pool and requires bonding. No bonding is required for storable pools if there is no metal in the pool or in the water. For permanent pools, if there is a metal wall or support, it must be bonded to the electrical ground. If there are no metal walls or supports, but there is a metal ladder or other metal components in or around the pool, it must be bonded to the electrical ground. Since the pool has a metal wall section where the filter lines go through, it is considered a permanent pool and requires bonding. The shiny metal wall section should be bonded to the electrical ground. The filter motor with a twist lock cord does not require a separate ground connection. However, the heater, if hardwired, requires proper grounding. It is recommended to hire a licensed electrician to perform the bonding and electrical work according to local codes. Use proper bonding clamps and a solid copper wire for the bonding connection. Regularly inspect the bonding connections to ensure they are secure and corrosion-free. If there is uncertainty about the pool depth or wall materials, consult with the pool manufacturer. Refer to local electrical codes for specific bonding requirements and procedures. Always follow safety precautions when working with electricity. In general, bonding is the process of connecting metallic parts of a pool and its surrounding area to form an electrically conductive path that ensures all metal components are at the same electrical potential. This minimizes the risk of electric shock. Grounding, on the other hand, is the process of connecting the electrical system to the earth, providing a path for fault current to flow back to the source, tripping a circuit breaker or fuse. This protects against electrical hazards. The National Electrical Code, or NEC, provides detailed requirements for bonding and grounding of swimming pools and related equipment. These requirements are designed to ensure electrical safety and prevent electric shock hazards. It's important to understand the difference between equipotential bonding and grounding. Grounding aims to protect against overcurrent conditions by providing a low impedance path for fault current. Equipotential bonding aims to minimize voltage gradients in the pool area, reducing the risk of electric shock. The bonding conductor must be a solid copper conductor of at least 8 AWG. This conductor is used to connect all metallic parts of the pool structure, including the metal wall section, reinforcing steel, metal fittings, and any metal equipment associated with the pool. The bonding conductor must be continuous and without splices. It should be routed around the perimeter of the pool and connected to each metallic component using approved bonding connectors. The bonding grid should extend at least 3 feet horizontally beyond the inside walls of the pool. This creates an equipotential plane that minimizes voltage differences in the pool area. Metal parts that need to be bonded include the pool's metal structure, such as the metal wall section, any metal ladders or handrails, metal diving boards, and metal slides. Also, metal parts of electrical equipment associated with the pool, such as the pump motor, filter, heater, and lighting fixtures, must be bonded. Any metal fences, gates, or other metal structures within 5 feet of the pool's inside wall must also be bonded. When selecting bonding connectors, ensure that they are listed for direct burial and are compatible with copper conductors. Use connectors made of bronze or stainless steel to resist corrosion. The connectors must provide a secure and reliable connection between the bonding conductor and the metallic components. The pump motor must be bonded to the bonding grid. Use a bonding lug on the motor housing to connect the 8 AWG solid copper bonding conductor. The bonding conductor should be routed directly to the bonding grid. The pool heater, if it has metallic parts, must also be bonded to the bonding grid. Use a bonding lug on the heater housing to connect the 8 AWG solid copper bonding conductor. The bonding conductor should be routed directly to the bonding grid. Junction boxes and conduit that are used to supply power to pool equipment must also be bonded to the bonding grid. Use a bonding bushing on the conduit to connect the 8 AWG solid copper bonding conductor. The bonding conductor should be routed directly to the bonding grid. If the pool has underwater lighting, the metal parts of the lighting fixture and the junction box must be bonded to the bonding grid. Use a bonding lug on the fixture and junction box to connect the 8 AWG solid copper bonding conductor. The bonding conductor should be routed directly to the bonding grid. The electrical panel that supplies power to the pool equipment must be properly grounded. This is typically accomplished by connecting the grounding electrode conductor to the metal enclosure of the panel and to the grounding bus bar inside the panel. The grounding electrode conductor must be sized according to the requirements of the NEC, typically based on the size of the service entrance conductors. The grounding electrode system should consist of one or more grounding electrodes, such as ground rods, ground plates, or underground metallic water pipes. The grounding electrodes must be installed in accordance with the requirements of the NEC. The NEC requires that all metal parts within 5 feet horizontally of the inside walls of the pool and extending 12 feet vertically above the maximum water level must be bonded to the equipotential bonding grid. This includes metal fences, gates, and other metal structures. The purpose of this requirement is to minimize voltage gradients in the area surrounding the pool, reducing the risk of electric shock. If there are any metal underground piping systems near the pool, such as gas pipes or water pipes, they must also be bonded to the equipotential bonding grid. This is to prevent stray currents from flowing through the piping systems and creating a shock hazard. The bonding connections must be accessible for inspection and testing. Do not bury the bonding connections in concrete or cover them with other materials that would make them difficult to access. Regularly inspect the bonding connections to ensure that they are secure and free from corrosion. If any bonding connections are found to be loose or corroded, they should be repaired or replaced immediately. When working with electrical systems, always follow safety precautions. Turn off the power to the circuit before making any connections or repairs. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, hire a licensed electrician to perform the work. Local electrical codes may have additional requirements for bonding and grounding of swimming pools. Be sure to consult with your local building department or a licensed electrician to ensure that your pool is installed in accordance with all applicable codes. The proper installation and maintenance of bonding and grounding systems are essential for ensuring the electrical safety of swimming pools. By following the requirements of the NEC and local electrical codes, you can minimize the risk of electric shock and create a safe swimming environment for yourself and your family. The NEC also addresses requirements for GFCI protection. Ground fault circuit interrupters, or GFCIs, are devices that protect against electrical shock by detecting small amounts of current leakage to ground and interrupting the circuit. The NEC requires that all electrical outlets within 20 feet of a pool must be GFCI protected. This includes outlets for pool equipment, such as pumps and heaters, as well as convenience outlets for general use. GFCI protection is also required for underwater lighting fixtures and for any electrical equipment that is used near the pool. When selecting GFCIs, choose devices that are listed for use in wet locations. These GFCIs are designed to withstand the moisture and humidity that are common in pool areas. Regularly test GFCIs to ensure that they are functioning properly. Most GFCIs have a test button that can be used to simulate a ground fault. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In addition to bonding, grounding, and GFCI protection, there are other electrical safety measures that should be taken when installing and maintaining a swimming pool. Keep electrical cords and equipment away from the pool. Do not use electrical appliances near the pool. Do not allow anyone to swim during a thunderstorm. Install a safety cover on the pool when it is not in use. Regularly inspect the pool and its surrounding area for any potential electrical hazards. If you have any concerns about the electrical safety of your pool, contact a licensed electrician. Remember that electrical work should always be performed by a qualified electrician. If you are not comfortable working with electricity, it is best to leave the work to a professional. Hiring a licensed electrician ensures that the work is done safely and in accordance with all applicable codes. An electrician can also inspect your existing electrical system to identify any potential hazards and recommend corrective actions. They can also provide guidance on the proper selection and installation of electrical equipment for your pool. Maintaining the bonding and grounding system over time is crucial. Soil conditions, water exposure, and general wear and tear can degrade the connections. It is essential to schedule regular inspections, ideally annually, to ensure the continued integrity of the system. Look for signs of corrosion on connectors and make sure that the bonding wires are intact and securely fastened. Any deterioration should be addressed promptly by a qualified electrician. When inspecting bonding connections, pay close attention to areas where dissimilar metals meet. Electrolytic corrosion can occur when different metals are in contact in a moist environment. This corrosion can weaken the connections and compromise the effectiveness of the bonding system. To prevent electrolytic corrosion, use bonding connectors that are specifically designed for use with dissimilar metals. These connectors are typically made of bronze or stainless steel and are coated with a corrosion-resistant compound. Also, consider using a dielectric grease on the threads of the connectors to further protect against corrosion. If the pool is located in an area with harsh environmental conditions, such as saltwater or high humidity, it may be necessary to take additional precautions to protect the bonding and grounding system. This may include using more corrosion-resistant materials, applying protective coatings to the connections, and increasing the frequency of inspections. If the pool undergoes any renovations or modifications, be sure to re-evaluate the bonding and grounding system to ensure that it is still adequate. Any new metal components that are added to the pool or its surrounding area must be bonded to the equipotential bonding grid. Also, any changes to the electrical system must be made in accordance with the requirements of the NEC and local electrical codes. Pool covers, both manual and automatic, can also introduce potential electrical hazards. If the pool cover has any metal components, they must be bonded to the equipotential bonding grid. Also, be sure to keep electrical cords and equipment away from the pool cover. Automatic pool covers typically have an electric motor that operates the cover. This motor must be properly grounded and GFCI protected. Also, a cover control should be located at least 5 feet away from the inside walls of the pool. During the off-season, when the pool is not in use, it is still important to maintain the bonding and grounding system. Remove any debris that may have accumulated around the pool and inspect the bonding connections for any signs of corrosion or damage. If necessary, clean the connections and apply a protective coating. Also, be sure to turn off the power to the pool equipment and cover the equipment to protect it from the elements. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a licensed electrician to ensure that your pool is installed and maintained in accordance with all applicable codes and regulations. The principles of bonding apply to other bodies of water, like spas and hot tubs. Metallic components should be bonded together and grounded back to the electrical panel that feeds the equipment. This will protect the occupants from electric shock. Fountains with metal components, especially if they have electrical pumps or lighting, should also be bonded and grounded. Follow local codes and regulations to ensure proper safety. In all these applications, using a licensed electrician is crucial for safe and compliant installations.